Hi, this is Irv Shapiro with the Dr. Vax channel. And today I may be making the most important video that I've made in the last 3 years. For just about 3 years, I've been creating videos teaching people how to use technology to make stuff. And a lot of those videos, I don't know, maybe 130, 140 of them have been about 3D printing. Over that period of time, I've had thousands and thousands of comments. I started a discussion group at forum.drvax.com, and there are over 1,000 people there that discuss how to use 3D printers. I have over 2.5 million views of these videos. So today, I'm going to wrap up everything I've learned in that 3 years and help you select a new 3D printer. It might be your very first 3D printer. It might be your second or your third, but the material covered in this video will apply to anyone, whether you're brand new or have quite a bit of experience in 3D printing. So stay tuned and let's learn something together. I'm going to cover a lot of material in this video. And for much of this material, I have specific videos on the channel. So make sure you subscribe. Click on the bell if you like this video so you're notified about new videos, and go to the Dr. Vax channel on YouTube and look for other videos to reinforce your knowledge of 3D printing. To get started, let's talk about 3D printer architecture. Let's look at this screen together. In order to produce a 3D print, whether you're printing a toy or a shelf bracket or a replacement part or a vase, you need to always do the same things. This particular video is all about FDM 3D printers. The first step is you need a model. Generally, those are produced with a computer-aided design program. The model produces a 3D representation in a standardized file format. A very common format is STL. 3D printers can't print STL files. They print G-code files or other files where the STL, the 3D representation, is encoded into individual layers that can be printed one at a time. The program that does this conversion between STL and G-code is called a slicer. You take your sliced model and you put it on an SD card, a USB drive, you send it over Wi-Fi, you send it over a USB cable, depending on your 3D printer. Inside the 3D printer is a control board. That's a computer. It's a computer generally either running an 8-bit chip or a 32-bit chip. That's not as important as you would think. We'll talk about it. But that computer is running a program that will accept a G-code file and will instruct the printer how to move the printhead or the print bed in order to print each of the layers. I own 13 3D printers. The majority of them I purchased. However, a few of them from ANET and from Monoprice were provided by the manufacturer for reviews. The most expensive printer is also the first printer I purchased. It's a Prusa i3 MK3. As a kit, which is how I purchased it, it was $750. Fully assembled, it's $1,000. I have a Monoprice Ultimate 2, which is a $500 fully enclosed printer that is very fast, but we'll see has a relatively small print volume. We'll discuss what print volume means in just a moment. I have two printers in the $350 to $450 range, a Quiddy X-Smart and an ANET ET5. The ANET ET5 is interesting because I replaced the firmware, the software inside the printer that accepts the G code and directs the printer mechanics, how to move. I replaced that proprietary software that ANET shipped with Marlin, the open source software. I have two printers in the $250 to $400 range, a Creality Ender 5 and a Monoprice MP10. One of my newest printers is a Creality Ender 3 version 2. A very, very good entry-level printer. Sells for about $250. And then I have a range of printers from a Monoprice Delta Mini, which I'm not a fan of. I could not get successful, consistent prints on that printer. An ANET ET4, original Creality Ender 3 printers, which you now can get for under $200 in some case. Monoprice Select Mini version 2, an entry-level fully assembled printer I really enjoy, and a Monoprice Cadet, which is an attempt by Monoprice to make a really, really easy to use printer. I think the trade-offs are not great. I'm not a fan of that printer. I have two more printers on order. I have a Monoprice Delta Mini version 2, which Monoprice is providing me at no cost to review. And I have a JG Maker Artist D Pro. This is a printer I'm really excited about. I believe the retail price will be about $600. They're just starting to ship. This is a dual color printer. So it can print with two rolls of filament at the same time on two separate print heads. So both print heads can be moving at the same time. A remarkable architecture. I'm excited to look at that. So I'm not going to recommend one of these printers to you today because printers change, 3D printers change monthly. Instead, I'm going to teach you how to select the 3D printer that's right for you using features from these various 3D printers as examples. These are the 18 different factors we're going to look at today. Yes, it's a lot of material. For each of these factors, I'm going to define the terminology quickly. There are videos available to watch where you can learn more details about each feature on this channel. And then I'm going to share with you trade-offs that I've learned over the last 3 years, both personally, but more importantly, from thousands and thousands of viewers. First, we're going to look at print volume. So print volume is basically the size of the object you can print. It's measured in X, Y, and Z dimensions. If we look at this table, we'll see that print volume does not necessarily correlate to price. The Monoprice Celeste Mini in my lab is the smallest printer I have. It's about a $200 printer. The Quiddy X Smart is next. It's a $400 printer. Why is it twice as expensive? Well, it does have a larger volume, but more importantly, it has a lot of additional features. Specifically, it's fully enclosed. We'll talk about that a little later. And it has Wi-Fi. It's the only printer I own that has reliable Wi-Fi built in. We'll talk about Wi-Fi some more later. I have the Monoprice Ultimate 2, which is $550. Also expensive. Why is that printer expensive? Well, it's a direct extruder printer and it's fast. The only printer as fast as the Ultimate 2 in my lab is the Prusa i3 MK3. I have a couple Creality Ender 3s. You'll see those are the next size. That's a very well-priced printer. I specifically recommend the version 2. There are advantages and disadvantages of the version 2 over version 1, but it's an excellent printer. I do have a Prusa, which I purchased as a kit for $750. Why is that so much more expensive than the Creality Ender 3? Well, the $1,000 version, which is almost 4 times as much money, is fully assembled. It has dual Z axes. We'll talk about that. But more importantly, every single component is higher quality. That means that overall, you can push that printer harder and it will print faster, reliably, consistently. But the other reason is sort of hidden, and that is Prusa provides exceptional support. Providing exceptional support is really quite expensive. You have to have a lot of staff. Staff gets paid. So a portion of the price you're paying for a Prusa printer is in the cost of the support. What does that support mean? It means they upgrade the software that goes with the printer almost monthly. It feels like it's continuously. We'll talk about that in a moment. And then I have an ANET ET5, which along with my Monoprice MP10 are my two largest printers. I'm actually becoming quite a fan of the ET5. It's priced well, and it does allow you to load Marlin on it, so you can use this open source software that's very powerful. So print volume is important, but don't buy more volume than you need. It takes up space, and printing larger things takes a really long time. Sometimes days, yes, days. So if you're printing jewelry, then potentially the Monoprice Select Mini is a great printer for you. If you're printing toys, small objects, replacement parts, even shelf brackets, well, something the Creality Ender 3 size will work just fine. So bigger is not necessarily better. Next, we're going to talk about extruder architecture. So overall, what is the extruder? Well, you have this roll of filament. You have to pull the filament off the roll. You have to push it into the hot end where it is melted and extruded out of a nozzle. Let's look at a picture that will explain this in some detail. On the left-hand side, you'll see a Bowden style extruder. The filament is pulled off the reel by an extruder that's not directly connected to the hot end components. It goes through a tube. That's called a Bowden tube. It then goes from there into the hot end. On the right-hand side, you have a direct drive extruder. The filament is pulled off the extruder, and basically the extruder is right on top of the hot end. The advantage of that is you can print faster. When you're sending your filament through this long Bowden tube that's flexible, there's a certain amount of give in that tube. One of the things you have to do with the 3D printer is pull the filament back. You're not actually pulling it out of the hot end, you're relieving the pressure so you don't end up with stringing. That's extra filament that's sort of dribbled on your print. That takes time to pull the filament back. When you're pulling it back from a Bowden tube, you have to pull it back more to be successful to get clean prints. So Bowden tube-based printers are inherently slower. However, because the extruder is not mounted right on top of the print head, they can be manufactured more cost effectively because that extruder adds weight. And if you add weight to the print head, you need more sophisticated, more robust mechanics in order to print reliably. So there are advantages and disadvantages. Most often, low-cost printers are Bowden tube printers, and higher-priced printers are often direct extruder printers. You can get excellent prints. The Ender 3 version 2 is an excellent Bowden-style printer for about $250. So you don't need to spend $1,000 on a Prusa to get good quality. Next, hot ends are not all the same. This is another difference between that $1,000 Prusa and all the other printers that I currently own. And that is, on the left-hand side, you'll see a PTFE style hot end. That's where the Bowden tube, or PTFE, which is the chemical name for Teflon, a Teflon lined or composite material, is pressed all the way down through the cooling area, which is the black fans, into the hot area. Now, what that means is that you cannot heat a hot end with a PTFE tube into the hot area really above about 260 degrees safely. Why? Because when you heat Teflon above that temperature, this is 250, 260 Celsius, when you heat it above that temperature, it gives off gases that are probably not good for you. So in general, you'll find that 3D printers that do not have an all metal hot end generally limit temperature to 250, 260, maybe 275 Celsius. The Prusa can print up to 300 degrees Celsius because it has an all metal hot end. On the right side of this picture, you'll see that there is a metal tube that goes from the cooling area into the hot end. Now, why is there a cooling area? Well, you want your filament to be soft, to be melted when it's coming out of the nozzle, but you don't want it to be soft when you're trying to push it into the nozzle. So you have a hot section and a cooling section, and in an all metal hot end, there's a metal tube between the two. Why doesn't everyone do that? It's much harder to cool down a metal tube than it is to cool down Teflon. So you have more potential for jams in a all metal hot end if it's not executed, if it's not engineered extremely well. All metal hot ends are generally more expensive than hybrid hot ends that use a Bowden tube going between the cooling section and the hot section. Another reason the Prusa is more expensive. Now, you'll see in advertisements for 3D printers, lots of people talk about filament out sensors. I don't get a lot of value from them. A filament out detector will work to shut off your printer, to pause your printer when it runs out of filament. It will do nothing for jams. It will do nothing if your filament stops moving because it's caught on the reel, it's tangled. Most of the failed prints are not because you run out of filament on the filament reel. On the other hand, most printers that have filament out detection also have power fail recovery. That is very useful, and the ability to pause the printer from the front console, make a change, and restart it. So since they all come together, it's good to look for filament out sensors because it will tell you it has those other features which are useful. In order to produce a successful 3D print, you need your print surface to be level. It has to be the same distance between the nozzle and the print surface everywhere it's printing. If it's on an angle, it will be closer here and further here. So it has to be as level as possible. The way you level this, the way you manually level this print surface, is by adjusting knobs generally underneath or little screws on the top. The bigger the knobs, the easier it is to adjust. So as an example, on the left-hand side, you'll see a picture of a ANET ET4, nice big knobs. The Enders from Creality, nice big knobs. On the right-hand side, you'll see a little older printer. This is the Monoprice Select Mini, and it's hard to see, but basically they're little hex screws, Allen screws you have to adjust on the top. They're a little harder to work with, but because they're on the top, it's not bad. There are printers out there where there's screws you have to adjust from underneath, or nuts you have to adjust from underneath. That is much more difficult to work with. In fact, the Monoprice Ultimate 2 does have nuts underneath. Now we'll see in the next slide that some printers have auto bed leveling, some do not. With auto bed leveling, you probably adjust manually your bed one time. Now, many people with auto bed leveling never adjust their printer. They think it just happens magically. You still auto adjust it manually to get it close, and the auto bed leveling will fine tune it. We'll talk about that a little more in a moment. So the first thing you should do when you get any 3D printer is if there's an ability to level the bed manually, you should do it. The Prusa does not. It's all done in software. I have 3 different types of auto bed leveling on my 3D printers. I have an Ender 5 that I added an Easy ABL to. The Easy ABL is a aftermarket bed leveling, auto bed leveling system that I bought from TH3D. The folks over at TH3D, Tim, their owner, their proprietor, fantastic folks. If you need aftermarket components, it's a good place to buy them. The advantage of a capacitive sensor is it's non-contact. It doesn't actually have to touch the bed, and it works with both metallic and non-metallic surfaces. The bed leveling sensor in my Prusa, which has an ABL, is an inductive sensor. The disadvantage of inductive sensors is they require a metal surface. That's why the standard beds are flexible metal sheets of various types for the Prusa. Now, if you have a sheet of glass on your 3D printer, we'll talk about why you would do that in a minute. Then if there's metal underneath, it probably will still work, but it'll sense the metal underneath. So your adjustments might be a bit different. And then on my Ender 3 version 2, I added a BL Touch. A BL Touch is a physical sensor. They're actually very easy to set up and calibrate. And I've had very, very good success with it. So I've had good success with all three types. I know people get passionate about what type of auto bed leveling system. I'm not. I want it to work. The one type I do not like is there are some auto bed leveling systems that you stick on the end of your nozzle, you level your bed, then you take the sensor off again. The original ANET ET4s were that way. I just didn't use it. I didn't find it useful at all. I want an auto bed leveling system that I can use to check the bed before every print. Yes, it takes a little bit of time. Depending on the number of points you're checking, it could take a minute or two or more. But I think it's worth it because there's nothing worse than a failed print an hour later because you didn't have good bed adhesion because your bed wasn't level. Now the control board in your printer, and you can see in this picture two examples, could use an 8-bit processor or a 32-bit processor. My Prusa original MK3 is still the fastest printer I own, and it uses an 8-bit board. My new Ender 3 version 2 has a 32-bit board. It's slower. So there are many things that impact speed of prints. The processor board is probably not going to be the primary component that impacts speed. What's the advantage of 32-bit boards? Well, they have generally a lot more memory space for the software that runs in the printer, which is called firmware. So you can have a lot more features. Now, Prusa does a remarkable job of putting a lot of features into a relatively limited memory space, what's called an address space, in their 8-bit boards. But in general, the newer printers are coming with 32-bit boards. And these 32-bit boards are going to offer more and more software features. Now, what about the control screen? First of all, I would not buy a 3D printer that does not have a control screen. There are 3D printers that have to be connected to a computer the whole time. That's a really bad idea, in my opinion, because unless you dedicate a computer to it, there are other things running on that computer. If you're going in and working on an Excel spreadsheet or a Word document or browsing the web while your printer is working, you're going to impact your computer's ability to send instructions to the printer at a reliable speed and pace, which can impact the quality of your prints. So you need a screen. Touch screens are not universally better. Yeah, they're easier to use. The touchscreen on the Quiddy is excellent. It's very responsive. It works great. The touchscreen on the ANET ET5 is not as responsive. It seems like you're always tapping it multiple times. And in fact, I end up using a stylus to tap it. Now, part of the problem is I loaded standard Marlin onto my ANET ET5. And standard Marlin is not optimized for a touch screen. So therefore, things tend to be close together. So when they're close together, clicking on the right spot with your finger sometimes is a bit awkward. The screen on my original Prusa is not a touch screen. it's ugly, it's single color, it works. I want a control panel that works. I don't get hung up on color, not color, touchscreen, not touchscreen. I have one printer that does Wi-Fi reliably, and that's my Quiddy. And it makes it much easier to use. If I'm using their slicer, I slice something which converts it from 3D to G-code. I click a button, it starts printing. Now it's not sending it continually to the printer. It sends the whole file to the printer. For all my other printers, the standard way to print is you save that G-code file to an SD card, to a micro SD card, to a USB key, to some type of memory device. You walk that over to your printer and you plug it in. Now, in fact, that works reliably. There is an alternative that I used for a while, but I find I don't actually use that much anymore. And that's called Octoprint. Octoprint is a program that runs on a Raspberry Pi. A Raspberry Pi is a single board computer, and you can buy one of these for about 50 bucks. And with a power supply and a case, maybe it'll come to 80, 90 bucks or so. And then Octoprint is free software you put on here. This provides Wi-Fi that you connect to from any regular computer, including a Chromebook. And then you send a file to this little computer, it sends it to your printer. Now, there are many advantages of Octoprint. It adds a lot of features. It adds the ability to check on progress. It adds the ability to see what's happening with your printer from remotely via a smartphone, via another computer, depending on the plugins and features you add to your Octoprint build. So Octoprint is really a remarkable piece of software, but very often for me, I'm printing on a printer that's somewhere within, 20 feet of where I'm sitting. And I turn around and I look. But if you're printing from another room or you want to leave your home or your office and leave your printer running, Octoprint is a very nice way to monitor it. And it does support using a webcam. So you not only can monitor it by looking at the progress, but you can actually see a picture of your printer. So Wi-Fi, nice to have, depending on your setting. If your printer is right next to you, sort of like your inkjet is right next to you, then I'm not sure it's a showstopper for me. Print bed surfaces come in all sorts of materials. And there's a lot of passion about print bed surfaces. In fact, I've noticed that from Creality, they keep changing. So the original print bed surface I had on my Ender 5 was a flexible magnetic sheet. It was okay. I noticed the Ender 3s had a fixed sheet originally. The Ender 3 version 2 has a sheet of glass with a material that almost feels like this material, a build tack type material on top. In fact, the Ender 3 version 2 sometimes sticks too well. Some people like printing directly on glass because it gives you a very smooth surface. And you can put a sheet of glass or buy a sheet of glass to go on top of any printer. But depending on your print surface, you have to check what ABL system you have. So if you intend to change your print surface, your auto bed leveling system has to be compatible with it. Remember, capacitive systems or with anything, inductive systems don't work as well if you have a sheet of glass there. Now, there are a variety, and we'll see on this slide, there are a variety of aftermarket surfaces. There's Build Tack, and MatterHackers has a product called Layer Lock. They both are aftermarket materials. And you can take Build Tack, which is a sheet. You just peel a sticky back on and stick. You can put it on any of your materials. I find Build Tack works very, very well as an aftermarket add-on, and it will not negatively affect an auto bed leveling system. Some people use an even simpler approach, which is masking tape. So I would not select a 3D printer based on the print bed because it's so easy to change to another material if you like. And a good way to get your prints to stick reliably and to release reliably is to use a print bed adhesive. I like using Magic Glue as my print bed adhesive. Some people think it's too expensive and they just use hairspray or Elmer's glue sticks, Elmer glue stick, not the liquid glue. And so there are many ways you can work on print bed adhesion. There's a good video on the channel just about it. Bottom line, don't select your printer based on the print bed because you can change it. Now, the software inside your printer that makes it work is called the firmware. The software outside your printer that is used to create the file for the firmware is called a slicer. Both of these can be proprietary or open source. What is open source? Open source means that the authors make the actual source code, the actual programs, completely free to use however you want. There may be restrictions about your ability to take their program and resell it, depending on the license, but generally it's free and available. They also generally make the source code, the instructions, the construction of the software available so other people can contribute to it. Two of the top slicers in the 3D printing space, Cura and Prusa Slicer, are open source. The top firmware, the software inside your printer called Marlin, is open source. Now, about half of my printers use open source firmware and half do not. Doesn't matter. Well, is your refrigerator open source? It has software in it. Is your car open source? It has software in it. Is this camera from Sony I'm using to shoot this video open source? It has software in it. It's firmware. They're not. So I don't get too hung up on open source or proprietary. I think it's important to look at the reviews and see if the software works reliably and has the features you need. Now, I did a whole nother video on open source versus proprietary. I'd recommend you take a look at it. Now, independent of whether you're using open source or proprietary software, you want to be able to upgrade the firmware, the software in your printer. To be able to do that, your printer has to have something in it called a bootloader. Not all 3D printers do. Bootloader is very simple. When you turn on a piece of electronics, a computer, let's say this Raspberry Pi, it goes to a particular place in memory and looks for a program and starts running it. Now, a bootloader is a special piece of software that they put at that place where you first go to when you turn on your computer that looks on the SD drive or looks on the USB cable to see if there's new software for the computer. And if there is, it loads it and then it runs the new software. So it gives you the ability to upgrade the software. There's a complex picture here about how that works. I have a video on the channel about loading Marlin version 2 into a computer that goes through this in detail. But basically, as I indicated, your computer goes to a particular address called address 0 to start, and it loads any new software it finds into, let's say, address 1000. Those would be hex numbers. Those addresses are made up. But basically, a bootloader allows you to load new software. It's a really important thing I would look for in your 3D printer. Now, once again, since 3D printers do not print three-dimensional objects that are modeled and saved in files, they print G-code. You need to be able to slice them. The only printer I have that receives outstanding slicer support is the Prusa. Once again, the Prusas are very expensive, but what you're paying for more than anything else is support. The Prusa slicer is updated on a regular basis, and it's synced with updates to the firmware, because we now know the firmware runs in the computer and the slicer feeds it a file that has G-code in it. All the other printers I have generally came with either old versions of Cura, another open source slicer, or profiles to be loaded into Cura. Cura is a great slicer. I use them both all of the time. But you want to make sure that the printer you're getting supports a current version of a slicer, that's a plus. You can't always get that. So you should go into Google, you should look around, you should determine whether the printer you're looking for supports Cura current version, or maybe even Prusa slicer. Now, some printers have profiles, those are the configurations for a slicer, built into either Prusa or Cura. So you can go to the Cura and the Prusa websites and you can see whether your printer is listed. If it is, that's a big plus. On the left, you see a picture of my Quiddy printer. On the right, you'll see the Prusa printer. And on the left, you'll see there's a single threaded rod in the middle. On the right, you'll see there are two threaded rods on the two ends. The Prusa is a dual Z-axis printer. The Quiddy is a single Z-axis printer. The majority of my printers, the ET5 from ANET, is dual Z, which is very, very nice, are single Z-axis. Why does that matter? Well, let's look at the picture of the Prusa. You'll see the printhead is suspended across those two Z-axes. If your printer does not have dual Z-axes, then the rod on the right will not be threaded. It will just be sort of hanging there free. So it's basically cantilevered, and it's going to move this side up and then it'll move the other side up, but it won't be as reliable. One of the reasons the Prusa produces very high quality, consistent prints is the dual Z-axes. But you know what? That's where size matters. If you have a smaller print volume, dual Z-axis doesn't matter as much. In fact, the Prusa Mini does not have dual Z-axes. If you're going to get a really big printer like the ANET ET5, you really want dual Z-axis because you want that X-axis to be supported on both ends, not just on one end, because it's very big. But if you're a little printer, like let's say the Monoprice Select Mini, wouldn't make any difference. It's a small printer. And in the Ender family, it's sort of in the middle. So the Ender 3 version 2 has a single Z-axis, and it produces very good prints. Now, your print bed in all these printers moves up and down. But the question is, does it also move back and forth? Well, on the Ender 5, which you see on the right here in this picture, the print head moves both back and forth and side by side in both directions. On many of the other printers that I have, the print head only moves side by side. So that means to print here or here, I have to move the bed because the print head isn't moving. Moving the bed takes a lot of force. There's a lot of weight there, the weight of your print, the weight of the bed. So you would think that printers such as the Ender 5, where the print bed only moves up and down, would produce higher quality prints. And that's really what I expected. But it's not always the case. The Prusa print bed does move back and forth, and it really moves fast. And it still produces very high quality prints. So print bed movement may not matter. Theoretically, a print bed that only moves up and down, the Monoprice Ultimate 2 print bed only moves up and down, and it produces high quality prints very fast. So it theoretically is an advantage. In practice, may not be. Now, fully enclosed or open. In theory, fully enclosed is always better. You get a uniform temperature inside, and it's quieter. Sounds all good. In practice, I don't recommend fully enclosed printers for most people new to 3D printing, unless you're going to treat your printer as an appliance. And the reason is it's hard to get to stuff to adjust it. 3D printers are mechanical beasts. There are lots of moving parts. You have to adjust the belts. You have to adjust the tension on gears. You have to make adjustments periodically. On a fully enclosed printer like the Ultimate 2, those are hard to make. Now, some 3D printers like the Quiddy, which is enclosed, the sides snap off relatively easily. So if you get a fully enclosed printer, check to make sure you can get access to the belts and the various components you're going to have to adjust in the future. Otherwise, go with an open frame printer. For most people, unless they're printing specific materials that need very precise temperatures like ABL, and most people getting started are printing PLA and PETG, then you really don't need a fully enclosed printer. Now, one caveat. Very often schools get fully enclosed printers because it keeps little hands out of there. And that's a legitimate use case. Price and selection. How do you go about selecting a 3D printer? Well, as I said, I'm not going to recommend a printer to you. What I am going to do is recommend you set a budget. You define must-have features that you just have to have. Maybe you have to be able to print high temperature. Maybe you have to be able to print large volumes. Select your must-haves. Then start Googling 3D printers, searching for 3D printers. You're going to find lots of them. Look on your various e-retailers, Amazon and others. Find 3D printers, a set of 3D printers in your price range with the features you need. Then start reading reviews. Look at all the YouTube reviews you can find. Just Google name of your 3D printer reviews. You're going to find lots of reviews. Go to forum.drvax.com and ask other people what if they've had any experience with this printer or heard anything about it. And then using the tools I've given you today, the knowledge I've shared with you today, select your first printer. 9 times out of 10, one printer versus the other isn't going to make a big difference if it's in your price range with the features you're looking for. This is a fantastic hobby, and it's even a fantastic addition to many small businesses. So enjoy 3D printing. Come back, watch more videos here, click the bell to receive notifications, subscribe to the channel, and let's continue learning things together.